op-amp Schmitt comparator. This is another used for wave shaping circuits, that is Schmitt trigger or Schmitt comparator. That is a special type of comparator with hysteresis implemented. That is the purpose is used for removed unwanted triggered. So Schmitt comparator is a special type of comparator with hysteresis implemented, used to avoid unwanted trigger. So as you see this circuit, that is a voltage divider, again an op-amp with input signal to the inverting type. So a resistive network is connected between the op-amp output and non-inverting input. When Vout is saturated toward the positive supply, real that positive VCC, a positive voltage with respect to ground, is applied to the op-amp non-inverting input. Likewise, when Vout is saturated toward the negative supply, real negative VCC and negative voltage with respect to the ground is applied to the op-amp non-inverting inputs. Since the two resistors are configured across the output in the form of voltage divider network, the voltage Vp present as a non-inverting input will therefore be dependent on the fraction of the output voltage feedback by the ratio of the two resistors. This feedback ratio is that beta is given as R1 over R1 plus R2. Note that we can make the value of that beta variable by replacing resistors R1 and R2 with potentiometer, in which the potentiometer wiper is connected directly to the op-amp non-inverting input, thereby allowing us to vary the feedback fraction. So this op-amp, it has a voltage divider in the output to the non-inverting inputs. It's depending on this one. So simply, let's to understand Schmitt trigger, let's show you first by a comparator, then let's show you again by during comparator circuit. As you know, our V reference VCC, let's say example 5 volt, this is R1, R2, 2K, 3K. This divider, that's what we call it beta, insert to the inverting input, that is V out. Non-inverting is applied voltage V in. Let's say example V in is becomes 6 volt. 6 volt or V in. So to find V out, to determine V out when V in greater than V reference, that our V reference is that V beta. So this beta or V reference to get V reference, that is voltage divider VCC R1 over R1 plus R2. So that means VCC is, let's say example 5 volt, R1 is 3K over 3K plus 2K. So that means 5 volt 3K over 5 k, k by k, 5 by 5. So this given beta becomes 3 volt. So plus, let's see, plus or minus 3 volt. So when in our circuit is our input is positive 6 volt. So let's show you the signal. -6 volt and -6 volt. Then our reference is 3 volt. That becomes 3 here, -3 here. This becomes, looks like this one. Then the comparator in V out we get when V in is greater than V reference. Look it in the output. When V in is greater than V reference, our output becomes positive. When V in is less than that V reference, our output becomes also negative. By this principle, we can make a comparator. But a Schmitt trigger is a special type of comparator with hysteresis implemented. That means it has two types of threshold. One, upper voltage threshold, and the second one, lower voltage threshold. That means upper threshold, lower voltage threshold, and initial signal that is 0. When you applied some trigger signal, let's say example like this one, our Schmitt trigger becomes that V out becomes, let's show you. Sorry for the drawing. Okay. Our V out becomes, look it, from 0 we get 0. When the trigger signal is above lower threshold voltage, that becomes high, until the trigger signal, the input signal or the trigger signal below the threshold voltage. When below the threshold, it becomes 0. Again, above the trigger, it becomes high. So this principle of working is a Schmitt trigger or Schmitt comparators. So that unknown input signal convert to the square wave or rectangular wave outputs. That sense depend on the upper threshold voltage and lower threshold voltage. That below of them, or I mean upper of them, or between of them, that it can be fixed as the outputs. So this principle becomes Schmitt trigger comparator or Schmitt comparator. So as the amount of hysteresis is directly related to the amount of feedback fraction, it is best to avoid constructing a Schmitt trigger op-amp. Regenerative comparator with very small amount of hysteresis, small beta, as this may result in the op-amp oscillating between the upper and the lower points when switching. If you place a feedback network across the Schmitt trigger between the output and the inverting input, we can control the amount of time that it takes for the Schmitt op-amp to change states. By doing this, the signal to the op-amp inverting input is now provided by the op-amp itself via the external arc feedback network, as shown this feature. Can also arc timing implemented. So basic op-amp monostable circuit, it looks like a Schmitt comparator. So this is Schmitt trigger, that is special type of comparator with hysteresis implemented. So the main purpose is to avoid unwanted trigger signal.